What if saving the planet means giving up on economic growth? Because that's the trade-off now confronting governments, investors, and voters worldwide as the global economy is at a crossroads where the urgent fight against climate change is clashing with economic growth ambitions. On one hand, the world has never been more serious about climate change as more than 145 countries that together account for roughly 77% of global greenhouse gas emissions have now set or are exploring net zero goals for the coming decades. And cutting pollution has become a global priority not just for preserving the environment, but for public health, energy security, and long-term economic stability. But there's a problem. The quickest way to cut emissions is to reduce the activities that produce them, which means using less coal and gas power, steel and cement, aviation, shipping, fertilizer, petrochemicals, and even parts of industrial agriculture. And shrinking those sectors comes with a cost because they're some of the largest employers and biggest sources of exports in the world. So if you shrink them too quickly, you're not just reducing emissions, but you're also cutting jobs, wage growth, and the pathways people use to climb the income ladder. That uncomfortable tension is what has pulled degrowth, a once academic concept, into mainstream climate discussions, because degrowth argues that on a planet with finite resources, countries should deliberately scale back resource-intensive production and consumption. And in theory, that means smaller, slower, and more sustainable economies with less waste, reduced emissions, and a tighter focus on well-being instead of endless GDP growth. And as climate science has become more urgent, the idea has gained momentum. Degrowth now shows up in reports from the Intergovernmental Panel on Climate Change and the UN Environment Program. And the concept is becoming more mainstream as books like Kohei Sato's Capital in the Anthropocene, which sold over 500,000 copies in Japan, have helped push degrowth into public conversation. But while degrowth has gained attention, the trade-offs it entails are becoming increasingly evident as well. For example, Europe has cut its emissions more than almost any region in the world, down roughly 37% between 1990 and 2023, while its economy has almost tripled. But the transition hasn't come without its costs, as carbon pricing and energy reforms have pushed electricity prices higher, squeezed factories, and contributed to protests like France's Yellow Vest movement. Japan shows that you can run one of the lowest emission economies among advanced industrial nations and still face decades of weak growth because of deeper structural issues like a rapidly aging population, low birth rates, and persistent deflation. And all this is happening in a world where nearly 700 million people still live in extreme poverty, surviving on less than $2.15 a day. And for these people, talk of degrowth sounds less like climate policy and more like a threat, because if rich countries stop growing, does that also close the door on development for everyone else? So we're left with a dilemma because we know the planet cannot handle business as usual emissions. We know rapid cuts will hit some workers and regions harder than others. And we know that telling nearly 1 billion people who have never experienced prosperity to just accept slower growth is both tone-deaf and maybe politically explosive. So as always, we've got some important questions to answer, which are, if cutting emissions is unavoidable, which parts of the economy actually have to shrink and which ones don't? How are countries already living these trade-offs today? And is there any realistic way to grow and decarbonize at the same time? Or is some form of degrowth inevitable? If you zoom out and look at where global emissions actually come from, the picture is pretty simple because most of the world's emissions don't come from plastic bags or people forgetting to recycle, but come from the unglamorous backbone of modern life. In other words, the stuff we rarely think about, which is energy, concrete, and steel, fuel, and food. And together these sectors account for the vast majority of global emissions. As it turns out, they're also some of the biggest employers and largest exporters on the planet, as heavy industry alone, which includes steel, cement, and petrochemicals, produces about 22% of the world's CO2 emissions. And if you zoom out further and include the entire building and construction sector, the share rises to roughly 37%. So to reach net zero, these industries can't just make a few minor improvements, because some of them need to change so dramatically that parts of them will inevitably shrink. Take electricity, because if the goal is to fully decarbonize, the world has to move away from coal and gas and toward renewables. And on paper, that sounds straightforward until you remember that in many places those fossil fuel plants are actually the economic anchors of entire regions. So when a coal plant shuts down early, it's not only workers who lose their jobs, because contractors also lose work. The local tax base shrinks, and the towns built around that plant start to hollow out, and we can watch that tension playing out across the world in real time. In the U.S., coal-heavy states like West Virginia and Wyoming face steep job losses as mines and plants scale down. In India, coal still puts food on the table for millions of workers. And in South Africa, where 80% of electricity still comes from coal, rolling blackouts are already a warning sign of how fragile the system is. So in places like these, shutting plants down too quickly risks destabilizing an entire region. And yes, the energy sector as a whole is still growing, as today it employs around 76 million people, with more than 5 million new jobs added since 2019. But that growth doesn't land where coal plants are closing, because new energy jobs cluster around manufacturing hubs, grid infrastructure, and clean tech supply chains, often far from the regions built around fossil fuels. So even if renewables look cheaper on paper, the real-world transition is far from smooth. Steel and cement, which account for 14% of the world's CO2, are even tougher to decarbonize. And the problem is that unlike many other sectors, they rely on both massive heat inputs and chemical processes that release CO2 no matter how efficient the factory becomes. Because, for example, turning limestone into cement clinker releases about 0.6 tons of CO2 for every ton of cement produced. And to put that into perspective, producing enough cement to fill an Olympic-sized swimming pool generates emissions that roughly match the annual footprint of a town of about 700 people. So until cleaner technologies scale, and we're not even close to that yet, cutting emissions in those sectors often means producing less cement and steel. And this has concrete human consequences because the world now uses about 4.2 billion tons of cement per year. So cut that supply and the effects cascade as first housing projects stall, then roads and bridges get delayed. And before long, contractors start laying people off and jobs quietly disappear from supply chains. In less developed countries, this has an even bigger impact because many are still in the middle of building the basics, anything from housing and hospitals to power plants and roads. So when materials become harder to get, that stalls the infrastructure that's supposed to unlock jobs, incomes, and higher living standards in the first place. Aviation and shipping face similar challenges because there are still no cheap, scalable, zero-carbon fuels ready to replace kerosene or bunker fuel at global volumes. So cutting emissions in these sectors today requires things nobody wants, like flying less. And right now, the world operates roughly 35 million commercial flights, with the biggest emissions coming from long-haul routes that tie economies together. So if we pull those back, we reduce emissions, yes, but the effects compound quickly. As some routes will disappear altogether, there will be fewer connections, and the flights that remain will become more expensive. Shipping is no different because more than 80% of global trade moves by sea, powered largely by heavy fuel oil, which is one of the dirtiest fuels in the world, and cleaner alternatives exist, but they're still too expensive or not available at scale. So cutting shipping emissions today mostly means shipping less stuff, which raises prices not just for luxury items, but for essentials like food, medicine, and building materials. And that hits developing countries the hardest as they rely on maritime trade for the basics. So for them, higher costs or disrupted routes hit food security, access to medicine, and economic stability directly. And then there's agriculture, because on the farm alone, emissions from livestock, methane, and fertilizer applied to soils make up almost 12% of global greenhouse gases. But once you factor in everything that brings food from the field to your plate, the entire agri-food system is responsible for roughly 1/3 of global emissions. And the problem is that cutting these emissions almost always makes food more expensive, because however you do it, whether using less fertilizer, raising fewer animals, or changing how farms operate, food costs rise, and no government wants to be blamed for making groceries unaffordable. It's true that precision agriculture, regenerative farming, and methane-reducing cattle feed all show promise in reducing emissions. But for now, they're still in early development, unevenly deployed, and not yet capable of delivering large-scale emissions cuts without higher costs. So this is the core dilemma, where short-term affordability is at odds with long-term environmental stability. And we've already seen what this looks like in practice. In Europe, tighter carbon pricing helped cut emissions dramatically, down roughly 37% between 1990 and 2023, but the transition came with a price as higher carbon prices pushed up the cost of energy, and that pressure landed hardest on industries that depend on cheap electricity to stay competitive. And yes, Europe's economy still tripled during this period. But that headline number hides something important because a big part of Europe's emissions drop came from shifting heavy industry abroad. As the EU still consumes huge amounts of steel, cement, and chemicals, but it just produces fewer of them at home. So those emissions didn't disappear, but were just outsourced to countries like Turkey, India, or China, where production is often dirtier. Now in rich countries with diversified economies, some of the changes that come from reducing emissions are manageable, as a shrinking coal sector in Denmark or the UK, for example, can be absorbed by service industries, tech, finance, or renewables. But in middle and low-income countries, it's a completely different story, because globally about 8.5% of the world's population still lives in extreme poverty, and billions of people rely on jobs in the very industries that climate policy says need to shrink. And for them, any decline in activity is a direct hit to wages, food security, and economic mobility. So yes, the world needs to decarbonize quickly, but the mechanics of doing that means some sectors will shrink, at least for a while, and many economies aren't ready for what that actually looks like. And some countries are already living different versions of this dilemma, and their experiences show just how delicate the balance between climate and growth really is. So let's look at a couple case studies. Take Japan, for example, because the country runs one of the most energy-efficient economies in the developed world with per capita emissions far lower than those in the US, Canada, or Australia, and Japan has also cut its overall emissions to their lowest level since national tracking began in 1990, even with a large population and a major industrial base. So in other words, Japan already looks like the kind of low-carbon society many countries say they want to become. So let's look at the other side of the scale, which is Japan's economy. Japan has now lived through 3 decades of weak economic growth because since the mid-1990s wages have barely budged once you adjust for inflation. And on its own, that's a slow grind. But paired with fewer stable career paths for younger workers, the pressure starts to build. And as the population ages, that pressure only compounds further with fewer workers carrying more of the load. And it's true that Japan's economic challenges have nothing to do with its emissions profile, but Japan's trajectory does show that running a low-emission, highly efficient economy doesn't automatically guarantee dynamism, rising wages, or upward mobility. So let's look at our second case study. Because if Japan shows environmental success with economic stagnation, Costa Rica shows environmental success with economic opportunity, as instead of shrinking its way to sustainability, the Central American country built an economy around it. Because in the 1980s, Costa Rica faced severe deforestation and environmental decline. But instead of doubling down on extractive industries, it reversed course by restoring its forests, which now cover more than 50% of the country, up from around 21% in the 1980s. And it turned environmental protection into the backbone of its tourism economy. But it didn't stop there, because it also shifted almost entirely to renewable electricity, with over 98% of its energy coming from hydropower, wind, and geothermal resources, while tech firms and service employers were drawn to its political stability and clean energy infrastructure. And while Costa Rica isn't a rich country by Western standards, it consistently produces higher life expectancy and stronger institutions than many countries at its income level. So yes, with early investment and the right strategy, you can grow and get greener at the same time. But, and this is important, Costa Rica is a small country with unique advantages, including abundant hydropower, political stability, and a strong service economy. So not every nation has those conditions. And you can't simply copy and paste Costa Rica's model onto India, Nigeria, or Vietnam and expect the same outcome. While Japan and Costa Rica sit at opposite ends of the spectrum, most of the world sits somewhere in between, as the majority of countries are trying to transition fast enough to avoid environmental disaster, but slowly enough to protect workers and the industries their economies rely on. And that brings us to the big question, which is there any path where the world can get cleaner without getting poorer? The first piece of good news is this: which is that not every part of the economy has to shrink because in fact some sectors will grow enormously, as clean energy is now one of the fastest growing industries on Earth. And last year alone the world added a record 585 gigawatts of renewable power, more than 90% of all new electricity capacity. While at the same time lithium-ion battery manufacturing crossed a milestone that was unthinkable a decade ago, which is the terawatt-hour scale. And together these changes are reshaping how energy is produced, stored, and used across entire economies. And the money flowing into the space reflects that, because in 2024 global investment in clean energy hit $2.1 trillion, nearly doubling what flowed into fossil fuels. And this means jobs, supply chains, and industrial clusters forming around clean energy, and it means parts of the economy really can expand even as emissions fall. But growth in one place doesn't guarantee fairness everywhere. Countries with cheap capital, strong institutions, or advanced manufacturing like the US, Europe, China, and South Korea capture most of the upside. Meanwhile, countries that rely on legacy industries like steel, cement, or fossil fuels face the risk of losing jobs faster than new ones arrive. So to pull off a transition that's both fast and fair, countries need three things. First, large-scale retraining, because workers in shrinking industries need realistic pathways into rising ones as they need actual job placement in industries that pay similar or better wages. And Germany's Ruhr Valley, for example, managed to replace part of its coal and steel employment through decades of investment in high-tech manufacturing and services, but many regions haven't done that. The second thing we need is targeted investment, because the most successful transitions happen when governments concentrate clean energy spending in specific places so entire new industries can take root at once. And when manufacturing, infrastructure, and suppliers grow side by side, they create entire local job ecosystems. And that makes it far easier for displaced workers to retrain, switch roles, and stay put instead of starting over somewhere else. The U.S. Inflation Reduction Act is one example as it poured hundreds of billions into domestic clean energy manufacturing, which has already triggered more than $110 billion in announced private sector investment, while China did something similar a decade earlier by building a solar and battery industry that now dominates global supply chains. But this kind of transition depends on deep capital markets, strong institutions, and room to absorb short-term pain, which many countries don't have. And that brings us to the third requirement, which is support for countries that can't afford slowdowns. Because low-income nations still need massive growth to lift their residents out of poverty, and telling them to slow down isn't realistic or fair. So if the global system demands rapid decarbonization, then the global system must also help finance it through green infrastructure loans, technology transfers, and climate finance commitments that actually get delivered, because without that, support the countries least responsible for historical emissions become the ones that pay the highest price. And that brings us back to the core dilemma, because a rapid transition is essential for the planet, a fair transition is essential for political stability, and a productive, innovative transition is essential for economic opportunity. So in the end, the real challenge is cutting emissions fast enough without breaking economies or leaving whole regions behind.